Welcome back. I am Matthew Woodford, and I have been discussing what is a robust process. This is my final and fourth part in my discussion, and we are looking at maintaining your robust process. The reason we have APQP, FMEA, PPAB is to design in all the controls and capability for a robust process before it is constructed. Trying to convert an existing poorly performing production facility into a robust process can be done, but requires time, often downtime whilst trying to support production, and at extra cost. To do this would be a whole new conversation. So we are going to look at our new production line. We've had it installed, it has been commissioned, and has been producing good parts. Like a new car, it drives every bit as it was designed to do and delivers a pleasurable driving experience. But if we fail to do our quality inspections that is expected of us, check the oil, check the water, check your tire pressures, all the basic daily checks that we should do if we are going out for a long drive or we're going somewhere where there's not much support or service. Those are the basic things we should be looking at. If we fail to do any one of these things, that driving experience could change to a negative one quite quickly. Ignore the scheduled maintenance intervals, and the reliability and performance will be compromised. We didn't take it for the 10,000 kilometer service. We didn't have the cam belt checked. That is putting risk into your performance of your vehicle. A production line, machines, gauges, they are no different. They all need basic checks and inspections. They all need scheduled maintenance intervals. So what do we need to do to monitor and maintain our robust process? Naturally, everything specified in our PPAB. But in this section, I want to focus on continuous improvement, SPC and MSA. Continuous improvement is driven by the philosophy of, if you're not improving, then you're standing still. If you're standing still in today's competitive environment, well then you're actually going backwards because your competitors are not standing still. No matter how well the process has been planned, there is always opportunity for improvements. There will be quality concerns, both internal or external. There will be performance breakdowns, information based on customer feedback, employee involvement teams, quality data analysis from market dynamics and technology improvements. We can continue to build a better and more efficient production facility. There are several tools to assist in continuous improvement. Kaizen, Plan, Do, Check and Act, PDCA, Six Sigma, Lean Manufacturing, Value Stream Mapping, SPC. Any one or more of these tools can help keep you focused on keeping your production facility robust. Let's look at SPC, as I said, or Statistical Process Control. Let's break that into two parts. We have process capability. Is the process capable? We discussed this in the previous voice chat. The capability assesses the ability of a process or operation to repeat within predefined specifications, defining the variation of the process to that of the tolerance limits. We use the indices CP, CPK or PP, PPK to quantify how well the process meets drawing specifications. Process capability should be performed at least once every 12 months minimum. So even if you had process capability at the beginning of your process launch, 12 months later, you should review your process capability on each of the pieces of equipment that you are using in your production line. Secondly, there are control charts. Control charts, on the other hand, are used to monitor the stability of the process over time. A typical X bar and R chart plots the performance of the process over time against calculated control limits, not tolerance specifications. I often get asked during training on SPC, are your control limits your drawing specifications? No, they are not. If you want to understand what your upper and lower control limits are, I suggest you get yourself on an SPC training course. Using control charts help identify trends, shifts, or other patterns that may indicate special causes of variation. These special causes of variation would require investigation and corrective action in order to keep the process under control. Any process, as we say, has variation. Everything we do has variation in it. So in a process, there is natural variation. That is accepted. It basically cannot be removed. It can be reduced. It can be minimized. But that would be normal process variation. When running control charts, should we get a shift, a trend, a pattern, an outer or above or below a control, upper or lower control line, that is indicating a special cause variation that is not part of the natural variation within your process. Those are the causes that we need to identify, to find the root cause and eliminate it so it does not come back. So we can say that capability analysis studies whether a process is capable of meeting the drawing specifications, whereas control charts monitor the ongoing performance and variation of the process. Both are needed if we wish to maintain our robust process. But that is not to say that we do SPC control charts on every operation. Not at all. The only advice I give to students is, where do we need SPC? Maybe your customer has already indicated that he wishes to have SPC control charts on certain operations or characteristics of the product that you are supplying them. If the customer has asked for that, well, that's a given. It's a customer requirement. Otherwise, use SPC where the reduction in variation benefits the customer. If the customer doesn't feel the benefit of a reduced variation in tolerance, well, then there's not really much need to employ control charts on that operation. Unless it's a project that you have installed something, you've changed the process, now you just wish to monitor it and see if what you have done to your process meets your expectations. SPC is a good tool to help you find whether the change to your process was successful or not. Otherwise, if the customer can feel the benefit of a reduced variation, then that is where you should be looking at applying control charts. As for MSA, Measurement Systems Analysis, we need to perform an analysis in order to ensure the measurements taken from a manufacturing process are both accurate and reliable. We know this more commonly as a gauge R&R. Has your gauge got an R&R report? R&R stands for repeatable and reproducible. It ensures that the equipment we use to obtain the data that we need to do or act upon and make decisions about is reliable, accurate, and capable of producing consistent results. So, and this has happened to me many times in real life. You're chasing shadows. You don't understand the measuring reports that are coming back. You've made the move. You've made a change, but it's gone the other way. I'm getting funny feedback. First thing I ask, where's the gauge R&R on this equipment? I want to see. And sure enough, the gauge is not repeating. It is not reproducible. So before we do any form of SPC or machine capability, it is imperative that the equipment that you are using to get data to make informed decisions about further actions is both accurate, repeatable, reproducible. So all the equipment that you need to use to help support you in all your measurements, from OEE, robust process, our capabilities, our control charts, we need to make sure our gauges meet the desired level of gauge R&R. So, I hope I have succeeded in defining a robust process and what tools we need for measuring and maintaining our robust production facility. Should you have any concerns or wish to join in conversation, I would be glad to answer you. You have me on LinkedIn. Other than that, thank you for listening.